All right, so here's our force diagram. Let's draw all the forces that are acting on the wheel. Here's the force that's going to push it up the curb. Here's the weight of the wheel acting at its center of mass. Then the curb pushes on the wheel. It's shown here resolved into its horizontal and vertical components. And then there would be a normal force here, but since we're solving for the instant that the wheel begins to move up the curb, that's when the normal force goes to zero. Just as the normal force goes to zero is when the wheel will begin to lift off the street and up the curb. So I'm going to strategically choose my axis of rotation to be right here because I have no idea what these forces are. But if I choose my axis of rotation to be here, then I don't care what they are because they pass through the axis of rotation. And then the torque about this point right here is only created by these two forces. So F creates a clockwise torque about this point, and the weight creates a counterclockwise torque about this point. And I'm trying to find the minimum F to get it up the curb. So that's just as it begins to move. So I can still say the sum of torques equals zero. It's the very last moment that the normal force has disappeared and it's just beginning to go up the curb. So it was in equilibrium prior to that. So this is that last moment of equilibrium. So that allows me to say it's equal to zero. And then each torque is produced by the force times the moment arm. And we look at the line of action. Here's the line of action of mg. So the perpendicular distance from the line of action to the axis of rotation is right here. So I can see in this diagram that is d. And then the line of action of F, here is the moment arm right here. This is the perpendicular distance from the axis of rotation to the line of action of F. And so right here is the same as right here. So that's R minus H. All right, so I know R and H, but I don't know D. So I need to get D in terms of R and H. So I'm going to use the Pythagorean theorem for this right triangle right here and solve it for D. There we go. So here's my weight times my moment arm, my force times my moment arm. One is positive, the other one is negative. F now is the only unknown. Solve for F, and there is my answer.